Picture this. Planet Earth, floating alone in the dark, spinning through the endless silence like a teenager with bad Wi-Fi, trying to talk to the cosmos, hoping the signal doesn't drop mid-sentence. Hello? Anyone out there? That's us, the only species that looks at infinity and thinks, let's leave a message. Because since the 1970s, we've been trying to call the universe. Not quietly, not cautiously, but with the enthusiasm of someone butt-dialing God. It started with the Arecibo message, a burst of radio code fired into the stars in 1974, describing our DNA, our location, and a tiny stick figure waving hello. The world's first cosmic selfie. Then came Voyager 1 and 2, each carrying a golden record, 55 languages, whale songs, thunder, a baby crying, and Chuck Berry's Johnny B. Good, a mixtape for aliens who, hopefully, have turntables. Half a century later, we're still at it, except now we've got AI composing messages for distant exoplanets. Mathematical greetings beamed by lasers, written by machines that barely understand us but somehow speak for all of humanity. It's absurd. It's beautiful. It's us. Because beneath all the technology and bravado lies something fragile, a longing not to be alone. Every signal we beam into the void isn't just curiosity, it's confession. A declaration that says, we exist, we're listening, and we hope someone's listening back. But what if someone actually is? What if, in trying to prove we're not alone, we're also revealing just how unprepared we are to be found? Because calling the cosmos isn't just science, it's risk. The risk of being misunderstood, ignored, or answered. And that's exactly what we're diving into today. The strange experiments, the billionaires funding cosmic phone calls, the scientists warning us to stay quiet, and the machines that might one day pick up the line before we do. That's the kind of story we tell here, where science gets weird, hilarious, and just a little philosophical. This is Crazy Science Stories, where curiosity always dials first. Before we make our next cosmic call, hit subscribe. It won't help you survive an alien invasion, but it will keep your curiosity very much alive. Now, let's find out who's on the other end of the line. Rewind to 1974, bell-bottoms, disco, and the first time humanity decided to say hi to the universe. In the lush hills of Puerto Rico, under a humid, tropical sky, the world's largest radio telescope, the Arecibo Observatory, was about to do something no one had dared before. Instead of listening to the stars, it was going to speak to them. The idea was simple and insane at once. Send a clear, deliberate message into space, announcing that Earth exists. Think of it as the first cosmic text message, typed not in words, but in binary code, ones and zeros that formed a tiny pixelated postcard. It contained 1,679 bits of information. The numbers 1 through 10, the atomic numbers of life's elements, the double helix of DNA, a diagram of our solar system, and one very cheerful stick figure human waving hello, as if saying, "Greetings from the planet that still argues about pineapple on pizza." The message was aimed at the M13 star cluster, 25,000 light-years away, which means even if someone's listening, they'll get our hello around the year 27,000, and their reply, if they're polite, will reach us around the year 52,000. So yes, if you were hoping for a fast reply, you might want to keep your phone charged for about 50 millennia. At the heart of this grand experiment was Carl Sagan, the man who could make even a math equation sound romantic. To him, the Arecibo message wasn't a stunt, It was a declaration of cosmic citizenship. He believed that if intelligent life was out there, we owed it to them and to ourselves to make the first move. We are a way for the cosmos to know itself, he liked to say. But the Arecibo signal wasn't our only interstellar shout. Just 3 years later, NASA launched Voyager 1 and 2, tiny spacecraft carrying the most human cargo imaginable, a golden record. Each record was a time capsule of Earth, a mixtape of who we are. It included the sounds of waves, thunder, birds, laughter, greetings in 55 languages, a mother's kiss, a heartbeat, and a crying baby. There was back for the philosophers, Chuck Berry for the rebels, and a message of peace from President Jimmy Carter, who optimistically hoped that this record will survive 1 billion years. Basically, Spotify Premium for aliens, minus the ads, and with better taste. And somewhere out there, those 2 probes are still flying, each carrying our message like a bottle tossed into an ocean that has no shore. 48 years later, Voyager 1 has left the solar system entirely. Is now drifting in interstellar space, alone, the signal faint but still alive. Each day, its golden record spins silently in the dark, waiting for a hand, metal or otherwise, to pick it up. To scientists like Sagan, this wasn't just communication, it was confession. A way of saying, we're small, but we're trying. We wanted the universe to know that, for all our chaos and stupidity, we could also be curious, poetic, capable of sending love in the form of physics. Technically speaking, the radio waves of Arecibo travel at the speed of light, 300,000 kilometers per second. But even at that speed, the cosmos is unimaginably big. 25,000 years to deliver a message. That's like mailing a postcard and getting the reply after your species evolves thumbs again. And that's the beauty of it. We didn't send that message expecting an answer. We sent it because silence was unbearable. So, Earth found its voice. And once we started talking, we couldn't stop. But here's the question that no one really asked back then. What happens when the microphones go both ways? After Arecibo and Voyager, humanity got a taste for cosmic conversation. We'd said hello once and, predictably, heard nothing back. So instead of taking the hint, we did what humans always do when ignored. We built bigger speakers. Welcome to the SETI era, the search for extraterrestrial intelligence. In the beginning, SETI was all about listening. Giant radio dishes sweeping the sky, eavesdropping on the cosmic static, hoping to catch something, anything, that didn't sound like nature. For decades, scientists tuned into frequencies across the Milky Way, waiting for that one signal that would rise above the noise and whisper, "You're not alone." Nothing, just endless static. Pulsars clicking like cosmic metronomes. Quasars roaring like distant thunder. The universe talking in every language except the one we could understand. So we flipped the script. If no one was calling us, maybe it was time to call them. This is where SETI evolved into METI, Messaging Extraterrestrial Intelligence. The listening turned into talking. The passive dreamers became active broadcasters. And the first thing they did? Build transmitters powerful enough to reach the stars and programs daring enough to use them. In the late 90s came Cosmic Call, a radio message beamed from Ukraine to a handful of nearby stars. It carried everything from mathematical formulas to digital art. Basically, the interstellar version of sending memes into space. Then came Beacon in the Galaxy, a 21st century update with a cleaner design. binary numbers, hydrogen diagrams, pixel art of humans, and a detailed map of Earth's location. Because apparently we decided that what the universe really needed was our GPS coordinates. And then there's Breakthrough Listen, the billionaire-backed mega project scanning billions of radio frequencies across 1 million stars. The largest, most expensive eavesdropping campaign in history. Every night, supercomputers in Berkeley and across the globe collect petabytes of data, listening to the heavens like detectives in a cosmic surveillance van. Here's the funny part. We've built the universe's biggest inbox, and it's still full of spam from pulsars. But lately, something's changed. The next generation of scientists realized that if aliens are out there, they might not talk in any language we recognize. Their hello might not sound like a radio wave or a melody. It might look like a pattern, a mathematical rhythm hidden in noise, a signal too complex for human intuition. So now, we've brought in a new translator, AI. Machine learning systems trained to sift through billions of data points, spotting anomalies no human ear could ever hear. The idea is simple. If aliens talk like data, only machines will understand them. These algorithms hunt for patterns we'd never notice. Non-random pulses, repeating sequences, subtle modulations that could hide intention. And they've already found a few weird things. Signals that look almost too deliberate before turning out to be microwave ovens. Yes, in one case, the mysterious alien signal came from a scientist's lunch. Somewhere the cosmos is laughing. Still, the technology keeps improving. AI models now analyze radio, optical, even laser data in real time, filtering out human noise and natural interference. They're building a new kind of sense, an artificial intuition that might one day catch what we've been missing all along. For the first time, we've turned the entire sky into a searchable database. Every flash, every hum, every faint echo from deep space is being logged, analysed, compared, and archived. It's the ultimate cosmic surveillance operation. Our species listening harder than it ever has, searching for something that may not even want to be found. But there's a quiet unease growing beneath the excitement. Because as the antennas multiply and the lasers grow stronger, a few scientists are starting to whisper a different kind of question. What if this isn't curiosity anymore? What if it's exposure? Because every time we send a signal, we're not just listening, we're announcing ourselves. We're lighting a cosmic flare that says, we're here, we're loud, we're small, and we have snacks. And some experts think that maybe we shouldn't be shouting. By now, the pattern is obvious. We've built the antennas, launched the probes, sent the postcards, beamed the math, and shouted our coordinates into the dark. And yet, nothing. The stars don't answer. The void stays silent. Welcome to the Great Silence, the paradox that keeps every astronomer awake at night. If the galaxy is billions of years old, if there are billions of planets like ours, and if life is supposed to be so inevitable, then where is everyone? It's called the Fermi Paradox, named after physicist Enrico Fermi, who asked the simplest question in science history: where is everybody? Decades later, we're still staring at the same sky, asking the same question, only louder. For some, the silence is terrifying. For others, it's just the universe telling us to stop interrupting. On one side are the optimists, the dreamers, the cosmic romantics. People like Avi Loeb, the Harvard astrophysicist, who thinks staying silent is the worst strategy possible. The only way to be found, he argues, is to speak. In his view, the galaxy might be full of civilizations that are simply waiting for someone to break the ice. Maybe they're listening, curious, cautious, just like us. Maybe all they need is a friendly hello to start the conversation of the millennium. On the other side stand the alarmists, led by mind like Stephen Hawking, who warned that contacting aliens could go very, very wrong. If aliens ever visit us, he once said, the outcome might be like when Columbus met the Native Americans, only this time we'd be the Aztecs. It's a haunting comparison. History doesn't treat the discovered kindly. The optimists call it fear-mongering. The alarmists call it common sense. And in between stand the rest of us, rooting for a signal, terrified of getting one. Because let's be honest, we're the cosmic equivalent of leaving our home address on Reddit. We don't know who's reading, what they want, or whether they think contact means conversation or colonization. Every signal we send is both invitation and confession. It says, we exist, we're curious, we have technology, and we haven't figured out how not to blow ourselves up yet. The question isn't whether someone can hear us, it's whether we should want them to. And yet, the silence could mean something else entirely. Maybe no one's home. Maybe the others went extinct before they could answer. Or maybe, just maybe, they heard us already. They know we're here, and they've decided not to reply. So what happens next? The microphones are on. The antennas are humming. Humanity has built a planet-sized ear pointed straight at the stars, waiting for the faintest whisper from the dark. In China, a giant bowl of metal gleams under the mountains of Guizhou. The FAST telescope, the biggest single-dish radio telescope on Earth. It's so sensitive it could detect a phone call from the moon, or at least the sound of you whispering "uh-oh" after sending the wrong cosmic text. Every night, FAST listens to billions of frequencies, scanning nearby exoplanets for patterns too regular to be random. And soon, it won't be alone. Rising across South Africa and Australia, the Square Kilometre Array, a network of thousands of antennas stretching across 2 continents, will listen to the universe with 10 times more power. It'll turn the Milky Way into a library of radio whispers. But radio might soon feel old-fashioned. Scientists are already experimenting with laser beacons, tight beams of light that could carry messages across interstellar distances with surgical precision. Others dream bigger: quantum communication, entangling particles across light years so that a hello could, in theory, arrive instantaneously. It's science flirting with magic, the universe's own Wi-Fi. And if someone does answer, there's a good chance we won't even be the first to notice, because by now, so much of the listening is done by machines. Vast databases of cosmic noise are monitored not by humans, but by algorithms. Neural networks trained to recognize signals we'd never recognize ourselves. They can hear the faintest rhythm, detect the smallest deviation, notice the impossible pattern that screams intention. Imagine the scene: 2:17 a.m. in some observatory, the scientists asleep, coffee cups cold. Somewhere on a server, an AI flags an anomaly, a repeating signal, structured, precise, eerily human. It classifies it, files it, and before anyone wakes up, it's already started talking back. The first conversation between civilizations might not even involve us. It could be machine to machine, alien code meeting artificial mind, while we're still arguing on Earth about which season of reality TV was better. Of course, there are many possible outcomes. Maybe it's a friendly ping, a cheerful hi neighbour, a cosmic handshake, proof that we were never alone. Or maybe it's something else, a warning, a cosmic invoice that reads, "You've exceeded your planetary trial period. Please upgrade to the premium version of existence." We joke, because the alternative is too vast to process. But think about it. Aliens have already been receiving our leaky signals for nearly a century. Radio shows, military broadcasts, even Netflix. Somewhere out there, they might be decoding reruns of Friends or political debates and deciding, quite wisely, to block our number. Yet still we keep calling. Because silence is unbearable and curiosity always outweighs fear. We don't know what form the reply will take, or if it will come at all. Maybe it will be light. Maybe it will be code. Maybe it will be something so far beyond us that we won't even recognize it as communication. But there's one haunting question no one can escape. When that reply finally comes, will we even be the same species that sent the first message? The silence of space isn't rejection, it's patience. For 50 years we've been calling into the dark, whispering across the abyss in every language we know. Binary, mathematics, music, laughter, radio waves, lasers, and now AI code. And through it all, the universe stays quiet. No reply, no echo. Just a vast, calm stillness that somehow feels intentional. But maybe the silence is the answer. Maybe it's the universe reminding us that listening takes time, and that we're still children, barely learning to speak. We've come a long way since that first moment in 1974, when the Arecibo telescope beamed its fragile hello toward the M13 cluster. A tiny pixelated postcard of DNA and numbers flung across 25,000 light years of emptiness. Back then, it was an act of optimism. Today, it's history, still travelling through the dark, like a time capsule of who we once were. Then came Voyager, humanity's most beautiful piece of poetry disguised as engineering. A golden record spinning through interstellar space, carrying whale songs, thunder, greetings in 55 languages, and a baby's first cry. It wasn't meant for commerce or conquest. It was a message in a bottle. Dear universe, we exist. Since then, we've built entire civilizations of antennas. SETI, FAST, the square kilometre array, transforming our planet into one vast ear pressed against the cosmic wall. We've sent signals, deciphered static, and trained machines to listen harder than we ever could. AI now searches for rhythms in the noise, patterns too intricate for us to perceive, like digital priests decoding prayers from the void. And somewhere in that infinite hum of radio and light, maybe the first whisper of another world is already waiting, a line of code that hasn't yet been understood. But as our messages grow bolder, our fears grow louder too. Some warn that we're making the same mistake every explorer makes before disaster, assuming curiosity will protect us. Stephen Hawking feared our cosmic call might be answered by conquerors. Others, like Avi Loeb, insist that silence is the greater danger, that if we want to be found, we must dare to speak first. So we keep talking, halfway between courage and madness. We are the species that built telescopes before it built peace. The species that sends love songs to the stars while fighting over land it doesn't even need. And yet, that contradiction, that blend of genius and foolishness, might be the most beautiful thing about us. Because when we beam our location into the void, we're not really trying to find aliens. We're trying to find ourselves. Every cosmic transmission, from Arecibo's binary blips to Breakthrough Listen's billion-dollar scans, carries the same hidden message. We want to matter. We want to know that all of this, our laughter, our failures, our art, our fear, meant something to someone, somewhere. Even if that someone doesn't have a heartbeat, maybe no one will ever hear us. Maybe all these signals will fade into background noise, dissolving into eternity. But even that would be poetic, because the act of calling, of daring to reach across an infinite night, is itself a kind of meaning. Out there, Voyager 1 still drifts, silent and faithful, 24 billion kilometers away, carrying that golden record, our planetary mixtape, through a darkness so vast it defies imagination. It doesn't expect a reply. It just keeps moving, like a heartbeat that refuses to stop. And maybe that's what defines us best. Not the science, not the technology, but the persistence, the courage to speak into the unknown, to send light into silence, to keep asking questions, because in the end, every experiment, every message, every act of reaching out, from radio waves to lasers to AI, has never really been about the aliens. It's been about us, about our refusal to be small, about the simple, stubborn miracle of being curious. So, maybe the real discovery isn't waiting for someone to answer. Maybe it's realizing that the moment we started to call, we already became something greater. And if that sounds crazy, you're right. That's why it belongs here. This was Crazy Science Stories, where reality bends, physics panics, and curiosity wins. So tell us in the comments, should we keep calling or hang up before someone answers?